Hi, I'm Matt, and in this video we are going to go over the various types of hydrocarbons and how to name unbranched hydrocarbons. So first, we're going to talk about what is a hydrocarbon. As the name suggests, a hydrocarbon is a type of organic compound that contains only carbon and hydrogen. There are four main types of hydrocarbons, and those are alkanes, alkenes, alkynes, and arenes. In this video, we're only going to focus on the first three and not on arenes, as arenes are very different from the other three. So first, we're going to talk about alkanes. So as previously mentioned, an alkane is a type of hydrocarbon, so it only has carbon and hydrogen. But what's particular to an alkane is that it only contains single bonds. So there's no double bonds, no triple bonds, only single bonds. And since there's only single bonds, we call this a saturated hydrocarbon, meaning no other elements could be added to it without removing something else. And since there's only single bonds and carbon and hydrogen, we actually use a formula to determine how many hydrogens there are. So that formula is CnH2n plus 2, meaning the amount of hydrogens is equal to twice the amount of carbons plus 2. So for an example, an alkane with 4 carbons would have 10 hydrogens, because 2 times 4 is 8, and then adding another 2 is 10. Similar to that of an alkane, an alkene is the next class of hydrocarbons, and also only contains carbon and hydrogen. But it differs from an alkane because an alkene contains a double bond in addition to the single bonds. The presence of the double bond makes alkenes unsaturated hydrocarbons. And the formula for how many hydrogens is that the amount of hydrogens is twice the amount of carbons. So in an alkene with 6 carbons, there would be 12 hydrogens present. And the last type of hydrocarbon we are going to talk about are alkynes. These contain a triple bond in addition to single bonds, and just like alkenes, are unsaturated hydrocarbons. The formula to determine the amount of hydrogens based off the amount of carbons is that the amount of hydrogens is equal to twice the amount of carbons minus 2. So for example, an alkyne with 2 carbons would have 2 hydrogens as well, because 2 times 2 is 4, and 4 minus 2 is 2. Now, to represent these hydrocarbons as well as any organic molecule, we want to use a structure to draw them out. But there's 2 different types of structures that we use. The first type is a structural formula. This shows all the elements present in the molecule, including all the hydrogens. Each element is represented with their symbol, such as a carbon being shown as a C, and bonds are shown as lines, as shown below, where the C's are carbons, the H's are hydrogens, and the lines represent bonds. The other type is slightly less straightforward, and those are skeletal formulas. This only shows the symbols for elements that aren't carbon or hydrogen, and the hydrogens are often omitted unless they need to be drawn to show something in particular. And the carbon is assumed to be shown at the end of each line. So if we look at the structure below, there's a carbon at each of the points and on the ends of the molecule, represented by the yellow dots. We don't write those out as carbons because they're assumed to be, and it's assumed that there's hydrogens attached to those carbons. Now that we've talked about types of structures, we could talk about naming unbranched alkanes or naming unbranched hydrocarbons altogether. So an unbranched alkane is an alkane where all the carbons are attached to each other in a row and there are no side chains. So if we look at some examples of unbranched alkanes that were on the last slide, we see that the carbons go, maybe not in a straight line, but in a line in such a way that we could draw them without picking up our pencil or crossing our path. For a branched alkane, that wouldn't be possible, because we see that when we get to the third carbon from the right, it splits into two other carbons. So one of those would be part of the main chain, and one of those would be part of the side chain. We're not going to focus on naming branched alkanes in this video, but instead focus on the unbranched alkanes like you see on the left. So now, let's go through the steps of how to name an unbranched alkane. So, to name an unbranched alkane, we need a prefix and a suffix. The prefix is determined by the amount of carbons in the chain, and it's shown in the chart on the right. So for example, if we had a chain of carbons that had 2 carbons in it, the prefix would be F. If we had 8 carbons in the chain, it would be oct, and so on as shown in the chart. I suggest you pause and copy down that chart, or take a picture of it as we will be referring to it throughout the video. And for an alkane, the suffix will always be -ane. So now, let's use these steps to try to name a hydrocarbon. And that's an alkane. So, we see these 2 molecules below. They're the same molecule, just the left is the structural formula, and the right is the skeletal formula. Since there's only single bonds, the hydrocarbon is an alkane. And since it's an alkane, no matter how many carbons, the suffix will always be -ane. Now, we need to figure out the prefix. To do this, we number the carbons. So if we number the structural formula from left to right, we get 3. And if we count the amount of points on the skeletal formula, we also get 3. Therefore, there are 3 carbons in this hydrocarbon. And therefore, using the chart, we see that the prefix will be prop. Therefore, putting the prop and the -ane together, we get that this molecule would be named propane. Now, we're going to move on to how to name an unbranched alkene. This is similar to an alkane, except there's more to the prefix than just the letters in the chart, because we also need to include a number for where the double bond is. We want to number the carbons so that the double bonded carbons have the lowest numbers possible. So for example, if we numbered from left to right and got that the double bond was between the first and second carbon, and then numbered from right to left and got that the double bond was between the 7th and 8th carbon, we would want to number them going left to right, since that would make the double bond between the first and second carbon, which is the lowest numbers possible. And in this case, we would put a 1-, because that's the lowest number and we want to represent that in the name. Here the example of 3- could also be done if the double bond was connected to the third carbon. The prefix is determined by the number of carbons, just like that from an alkane. And then for an alkene, the suffix will always be -ene. So now, let's try an example with this. Once again, the picture on the left and on the right are of the same molecule, just that one's drawn in structural and one's drawn in skeletal. Since there's a double bond, we know that this hydrocarbon is an alkene, and all alkenes have names that end with -ene. So now, we need to number the carbons so that the double bond has the lowest possible number. So if we number the structural formula from left to right, we get that the double bond starts at the 4th carbon, while if we number from right to left, we see that it's attached to the 2nd carbon. Looking at this with the skeletal formulas reveals the same thing. Since the lowest possible number for the double bond to be connected to is 2, the name will start with a 2-. Now, no matter how we numbered, we also got that there are 6 carbons in total. Therefore, the second part of the prefix will be hex. Putting the 2-, the hex, and the -ene together, we get that the name of this hydrocarbon is 2-hexene. Lastly, we're going to talk about how to name an unbranched alkyne. Just like an alkene or an alkane, we need a prefix and a suffix. Here, that prefix will contain a number and a word. The number comes from the number of the triple bond, and we want to number the alkyne so that the triple bond has the lowest possible number, just like we did with an alkene. And we put this low number followed by a dash to start off the name. The prefix will then be determined by the number of carbons, just like we have in the past, and the suffix for an alkyne will be -ine. So now, let's try to use these rules to name one. So these two structures are the same, the left is the structural, and the right is the skeletal. Since there's a triple bond, we know that this is an alkyne. And to name an alkyne, the suffix will be -ine. Now, we need to figure out our prefix. So numbering the structural formulas from left to right, we get that the triple bonded carbon starts on the first carbon, and numbering it from right to left, we get that the triple bond starts on the third carbon. The same thing can be seen using the skeletal formulas. Since the triple bond has its lowest possible number on the first carbon, we're going to start the name with a 1-. And no matter how we numbered, we should have gotten that there are 4 carbons, so the prefix will be bute. So putting this all together, we get that the name of this compound is 1-butene. Now that we've gone through naming and the types of hydrocarbons, we have 4 practice questions to test your understanding. So the first one is, which of the following types of hydrocarbons is considered saturated? The second one asks you how many hydrogens there are in an alkene that contains 6 carbons. And question 3 gives you 2 compounds that you need to name. At this time, I suggest you pause the video, and the answers will be provided for you on the next slide. So the correct answer to the first one is alkane, because alkanes are considered saturated because they have all single bonds. For question 2, we needed to double the amount of carbons, as is the formula for an alkene, so the correct answer was 12. For question 3a, we should have gotten the name as butane, because there are 4 carbons in a row, so we have but as the prefix, and then it's an alkane, so the suffix should have been ane. For question 3b, we should have gotten 1-pentene. Because it's an alkene, the suffix will be ene. There's 5 carbons, so it's pent. And then we get a 1- because numbering from right to left gives us that the lowest possible number for the double bond is 1. Now, there's one additional practice question that's a little bit more challenging than the others. Which of the following hydrocarbons has a double bond? Once again, I suggest you pause the video and try this. The correct answer would be C, 1-nonene. To do this, we see that we have to look at there's a double bond, and we know that to have a double bond, it has to be an alkene. And we know that alkenes always have to end in ene, so we had to look for which of the choices ended in ene, and the only choice that did that was choice C. Hopefully you got these. If not, feel free to leave any questions you have in the comments below. Thank you so much for watching. Have a great day.